Ladies and gentlemen, very welcome to join SEMI Heterogeneous Integration panel discussion with Global SEMI member online. I'm Anna from SEMI Taiwan. First of all, we would like to wish you and family all well and healthy. Walking through the outbreak of COVID-19, we provide the most updated technology and market to our SEMI member worldwide through various channels, just like today's event. While we hear a lot of debate within the IC industry, whether Moore's law continues to be the golden rules that's guiding the development of IC, we at the same time see the emergence of heterogeneous integration. Heterogeneous integration is like the new alternative that's leading the IC industry to the new blue ocean market. So all the players want to be part of it. So what's the charm of heterogeneous integration? Today, we are very excited to have the opportunity to invite leaders from all the IC ecosystems to join us to share their perspectives on how they see the opportunity and challenges of heterogeneous integration. And we would also like to ask them, under the dynamic development of 5G and AI, what's the role that heterogeneous integration plays? Before I start, here's some housekeeping note I would like to remind you. So for all the audience online, please help us to keep your mic mute and also your camera off. And we very encourage all the members online to share your question and thoughts through our chat room function. Our staff will assist you. And also, in order to provide you a very customized experience of joining our event, feel free to adjust the slides proportion and also the video part based on your own preference. So here is our agenda today. For our panel, we will firstly invite all the panelists to give a 3-minute sharing on their position and perspective from high level about heterogeneous integration. Then we will move on to the main part, which is more in-depth discussion of heterogeneous integration. And lastly, we will have a Q&A session, which all the members online, the question you raised, we will have our panelists to respond in this part. So firstly, I would like to invite our panelists to each say hi to all the audience online. First, I would like to invite our Dr. CP Hong, Vice President from ASE, who is also the chair of SEMI Taiwan Packaging and Testing Committee. Welcome, CP.
Thank you.
Next, I would like to invite Mr. Leroy, General Manager of Dialog Semiconductor. Next, Dr. Yuhua Chen, Vice President of Carrier SBU, Unimicron.
Hi.
Mr. Julian Sun, Director from Cadence.
Hi, hello everyone.
Dr. Shijie Zhang, Executive Secretary of AI on Chip Taiwan Alliance.
Hello, hi.
And Mr. Charlie Zhen, Executive Director from Morgan Stanley.
Hi, good afternoon.
Okay. And of course, we would like to especially thank our co-organizer, AI on Chip today, and also our sponsor, Cadence. Without their support, we wouldn't be able to make today's event possible. I know you are all very excited to hear what's the discussion, our panel discussion of heterogeneous integration. But just before we start, please allow me to have 2 minutes of your time to briefly go through the platform that SEMI provides in Taiwan for heterogeneous integration. As most of the members online know that SEMI is a global microelectronics industry association. We connecting 2 trillion microelectronics supply chains starting 50 years ago. So this year is actually our 50th anniversary. And we start from equipment material company. We expand to manufacturing, design, system, and now we are also serving 5 major initiatives from the application side, as you could see from the slides. From the left-hand side, smart data, which is AI, and smart manufacturing is a major topic here in Taiwan. Smart medtech, IoT, and also smart mobility. These are all the major initiatives that SEMI is supporting right now. So in Taiwan, for heterogeneous integration, what does SEMI do? The first thing you can see on the left-hand side is our SEMI committee. Committee is one of the most valuable and long-established platform in SEMI. And among them, Packaging and Testing Committee, which our chair is here today, CP. It's also the longest history one. Under CP and many industry leaders' leadership, we continuously discuss the technology advancement and market opportunities of semiconductor through this platform. And under our committee's leadership, we also have different technology promotion opportunity, like the one you see in the middle, which is the Heterogeneous Integration Summit. And others are like semi-standards. We also talk about the development of 3D packaging and integration. Another activity I believe most of you have attended before is SEMICON Taiwan. And I would like to especially introduce our signature event, which is SIP Global Summit. This year, we are pleased that the forum theme of the 3 days have all confirmed. The first day is about advanced packaging, which we will invite speakers from equipment and material side and also software to share their perspective. And for day 2, we will talk about Moore's Law 2.0, led by TSMC. And for day 3, we will have the expertise from OSAT, including ASE and SPIL, to talk about the various innovations of SIP. And on the show floor, we have Heterogeneous Integration Innovation Zone, with our theme this year is 5G and AI, which we will invite companies from service, also design, manufacturing, and the entire ecosystem to share their perspectives. Okay, so without further ado, I would like to invite our panelists to each give a 3 minutes sharing of how they see the opportunity and challenge of heterogeneous integration. So firstly, please allow me to invite CP.
Thank you, Anna. And thank you, SEMICON Taiwan, set up this nice platform. I think this is the first time that we are having this online sharing panel. So to start with today's heterogeneous integration panel, actually, there's very nice starting point we'd like to mention. Back to year 2016, the ITRS, they decided to migrate themselves to HIR, Heterogeneous Integration Roadmap. The purpose is to really extend from the chip, everyone thinking all the integration is starting from chip. And but when people start to find out, all the industry experts start to find out, the packaging solution are also offering a lot of opportunity. And also the various system technology, they are also offering a lot of technology. And even the substrate technology, they can all offer a lot of various technology to enable different sort of integration. So that the HIR working team, they are transforming themselves, for example, starting from different application, like high-end computing, like for wireless connectivity, like for silicon photonics application, so that you can see a lot of different applications they are going into this heterogeneous integration trend. So today in our different panel, I believe you will hear a very comprehensive discussion and also interesting point. Okay, let's looking forward for this following discussions.
Thank you very much, CP. Next, I would like to invite Charlie from Morgan Stanley.
Thanks, Anna, and thanks for the invite from SEMI. Good afternoon. And from our perspective, we see lots of demand for those heterogeneous integration to enable the application in 5G, AI, and IoT. So maybe I touch base on some key forecasts from Morgan Stanley to see how strong demand will be. So first of all, on the AI 5G, we see a much higher semiconductor content versus the 4G era. So if you look at today, the ASP for the 5G SoC is around 2x versus 4G SoC. And into the second half, we do see China 5G smartphone penetration is going higher. So this year, we are going to see around 240 million units of 5G globally, and the 140 million units will be from China. And next year, we think that 5G phone is going to be 2x. And among the others, the millimeter wave phones should be around 30 to 40 million units this year. And they definitely need the AIP technology, which used heterogeneous packaging service from the backend supply. And the millimeter wave can also enable a lot of industrial and autonomous driving demand. So that is something that we think millimeter wave can create a lot of value. So according to our forecast, we think 2022 will be the time that the millimeter wave will become kind of a mainstream 5G technology in the US. And regarding the AI end markets, it is very important to the future, the industrial upgrades and also the consumer technology. And for that AI computing, we do need better interconnects between the logic and the memory, and that requires a very high-end advanced packaging technology. So that's why not just the back-end foundry, but also the front-end foundry like TSMC is also spending a lot of investments to enable this future AI packaging application. And lastly, maybe some focus on the autonomous driving. So we think for autonomous driving by 2050, it's around 30 years later, it could become a $800 billion US dollars market size because it is going to consume a lot of data. For example, autonomous driving, according to our forecast, is going to consume 2 gigabytes per hour data versus our mobile phone today is around 100 megabytes per hour. So it's going to be 20x demand from autonomous driving. And among the others, the semiconductor is going to play a key role. It's going to account for 10% of that 800 billion US dollars. So it's going to be 80 billion US dollars semiconductor contents from autonomous driving in the coming 30 years. And lastly, I think one thing that also need SIP is the IoT. So IoT includes surveillance, including drone, including those industrial IoT. But we think of wearables, they need a smaller form factor. And as we can see today, a lot of new features like healthcare features will be embedded into the wearable devices in the future. So we definitely need a better heterogeneous packaging technology to include those features. And we are also seeing more applications. For example, the item tracker. For example, Tile is a more established item tracker vendor in the US. But we think Apple will also introduce their own item tracker maybe by the end of this year. So I think that is also going to be another key growth driver for SIP. Maybe I stop here and hand it over to the next panelist.
Thank you very much, Charlie, for giving us a lot of positive opportunities for SIP and also heterogeneous integration in general. Next, we would like to invite the representative from Design House, Leroy, please.
Thank you, Anna. Thank you, Sammy, and all the panelists. This is Leroy speaking, of course. I would like to say it's a bit interesting for me when it came out to me about the heterogeneous integration. Since we're from the semiconductor side, of course, that probably we will start from the semicons. While I was doing some of the brainstorming regarding to the, probably we have the different the IT organizers or manufacturers from the platforms, from the device-wise, the platform-wise, and then to the semiconductor industry. So from this perspective, I would like to say about the heterogeneous meaning to me for the device partners, it probably would be from the cloud with the communication with the device, and for the platform, probably it would be with the PaaS, as of what I learned from KC of Advantech, the chairman, like the platform as a service, for example. And then for the semiconductor, what we're driving every day to survive is probably with the SIP, working with the packaging house and try to find with the best optimized on everything on substrate to integrate to go forward. Well, as the standing point from the investor perspective, if we don't have investors, I won't be able to be sitting here, right? So I would come out with the two directions. One is the Blue Ocean strategy committees for this heterogeneous integration part, and then to make money for the company. Otherwise, where is the purpose for us to do the heterogeneous integration? And then the second part is the optimization. Because of all the AIoT on chip, AI on chip, and then all the IoT on chip, for everything on chip or on wafer or on substrates. And I mean, this should be optimized. Otherwise, the real performance won't be shown without the cost structure. So let's see and let's listen. Thank you.
Thank you very much, Leroy. I like your approach, very practical.
You mean the hello part?
Next, I would like to invite the representative from Substrate, Yuhua from Unimicron.
Thanks, Anna, and thanks, SEMI organized this panel discussion. I think previous Leroy also mentioned the substrate also is very important. So I think this is a good opportunity from the substrate side because heterogeneous integration is a good opportunity for substrate because there are many things need to integrate on the substrate. So from us, of course, we got a lot of requests, but also, the challenge also very huge because this is not by using the conventional technology or method we can achieve. We need to cooperate with all the, I would like to say the customer or package house, or even the material or tool suppliers. So I think this is a good opportunity for all the semiconductors, maybe not only semiconductors, all the related with the heterogeneous integrations. We need to work together to achieve our goal and to get the money for everyone. Thank you.
Thank you very much, Yuhua. I think you point out a very valid point, how to create more opportunity while at the same time avoid risk when we develop heterogeneous integration. As EDA tools also play a very significant role in advancing the advancement of technology. So next, I would like to invite Julian to share your perspective.
Hi, hello everyone. Hello panelists. And thanks for SEMI to give opportunity that the Cadence can as a sponsor for this event. And as an EDA vendor, I think the heterogeneous integration is very hard topic for everybody. And I would like to make some definition to answer Leroy about the definition about heterogeneous integration. To Cadence, heterogeneous integration is about the disaggregate SoC. Okay, so we are talking about not only about the traditional design from the IC design house to the foundry to the offset, but we would like to have a new kind of a technology that is introduce those kind of idea like a so-called chiplet. Okay, it's not everything need to redesign or develop in the new node. Okay, like not everything that you need to have a DDR in the 7 nanometer and the redeployment at the 3 nanometer. So you can have a different kind of idea to combine each other like soft IP and hard IP and the so-called chiplet. Okay, we should put everything together. So not only from the SoC that we like to introduce some idea about you can put everything in the packaging. So everybody is talking about 2.5D and 3D IC, that 3D IC SoC. Okay, so those kind of idea that's very hard to everybody to discussion how to do it. And EDA vendor, Cadence as the EDA vendor, that we are very interested to support those kind of technology to conquer those kind of challenge like through silicon via TSV. And we like to have a different kind of idea how to make the so-called 3D stack for the for the bare die, or different kind of idea like HBM, okay, high density memory, okay. So those kind of technology will be very important for everybody. So we are try to solve those kind of problem like a pin pitch, thermal, okay, and electrical power problem. Those kind of model is very difficult to solve from die, from the packaging, and also to the system, because every chip need to bonding into system to develop to the end customer. So that is very important. If we can have a multi-physics idea and to conquer those kind of simulation and analysis and look back to the constraint from the design side, that will be very important for each of the customer. So they can save a lot of money and increase the time to market things. And we can benefit to Taiwan as a Silicon Island, and we focus on those kind of IC design. We are booming, and we have a very strong foundry and also at Taiwan. So this is a good opportunity that everybody can leverage about the heterogeneous integration, not only from the die, from the IC side, but also to the like a unicorn, that we can leverage those things not only from silicon but also with the organic substrate. Okay, so everything should be binding together to bring out more value to everybody. Okay, so this is idea that Cadence see.
Thank you very much, Julian, for defining the scope of heterogeneous for us. Basically, just like what Julian mentioned, I think it's not only for a certain segment of the IC system, it's actually from manufacturing all the way to design and also to end application to make it really possible. So next, I would like to invite Shijie to share his perspective. Welcome.
Anna, thank you. Hi, everybody. It's my honor to be here. As Anna said, that I'm representing for an industrial alliance called AI on Chip Taiwan Alliance. It's abbreviated to be ITA, pronunciation similar to Love Taiwan. This alliance right now, we have 97 members right now, ranging from the IC design, packaging, foundry, software, and also system integration house. Under this alliance, we have a very important special interest group called Heterogeneous Integration. Now, this SIG is led by CP Hong here. Under his great leadership, we have a very clear 4-year roadmap to improve the interconnect bandwidth and also to improve the power efficiency. Now, not only that, in very short term, by the end of 2020, this SIG is going to demonstrate an AI IoT platform. So compared to the previous one using low-level integration, now we are going to show using packaging technology, they can demonstrate advantage on power reduction, on performance improvement, and form factor reductions. So on the other hand, that I'm also representing for ITRI. So ITRI has been working on heterogeneous integration for many years, probably say more than 20 years. So couple of things that we are currently doing, and we believe they are important. For example, we believe that how to increase the interconnection performance is important, and the solutions such as bumpless hybrid bonding, that could be a possible good solution. And how do we do this hybrid bonding in a very low temperature will be also key. In this case, we are also working on a case they can do more than 1 million pair-to-pair bonding. So another case, we believe that how do we do a flexible architecture for interconnection? This is also important. For example, this is similar to the Intel EMIB solution. However, we also believe that how do we make each die to be flexible? This also be the key part for this flexible interconnection. Finally, that we find that maybe there's some needs for low volume productions. And in ITRIS, in the future, we are going to build this service platform, and we welcome others to use this platform. This is all I have. Thank you.
Thank you very much, Shijie. I believe from the brief sharing from all the panelists, we already hear some keywords: blue ocean, business opportunity, optimization, and cross-ecosystem collaboration, and also the challenge of small volume manufacturing. So next, we would like to move on to the panel discussion part, which we have prepared 2 questions. But of course, at the same time, I would like to remind all the audience online again, if you have any question or thoughts to share, feel free to use our chat room function so we could have further discussion at the Q&A session. Okay, so the first topic, what are the challenges and opportunities of heterogeneous integration? As our previous sharing ended by Shijie, so maybe I could invite Shijie to be the first one to share his thought. Welcome.
Okay, so I'd like to talk about some of the challenge and opportunity here. That in ITRI, we have 2 observations. One is that, as other panelists mentioned, that the heterogeneous integration has made tremendous progress recently. However, we feel that some of the advanced technology or some wonderful technology, they are currently only used or enjoyed by few large companies. And secondly, that as I just previously mentioned, that we think that it is difficult right now for people who want to use a low volume production to find an available manufacturing platform. For example, that one of my friend, professor friend, his startup company want to produce medical devices, probably like a couple of hundred modules per year. And he told me for him, it's very difficult to find people to manufacture this product for him. So therefore that, as I just mentioned, that each ourselves in the very near future, we would like to build or establish this manufacturing service platform for some advanced technology such as phenol or for some low volume productions. However, that we understand that to build this platform, we are not just to buy or integrate those expensive machines together. So there are several challenges to do so. First of all, we believe that when you come to low volume production, yield will be a very serious issue because there are very little motivation to try to make the high yield for low volume. Therefore, in ITRIS that recently we have spent a lot of effort, energy, try to explore innovative way so that the yield could be high. I would just briefly say how this can be done. So I always like to use this analogy for IC design. We know in IC design, for large volume, we use standard cell design style. However, when it comes to low volume, we may use gate array style or FPGA style. Now, you can find that both the gate array or FPGA, they have regular architecture, they have redundancy. So similarly, that we will investigate what are the parts that will have low yield in the future implementation. So we prefabricate those as a regular structure with some redundancy. And we believe that this will increase the yield. In summary, that we think that there are some needs for low volume productions, and we are going to build this platform, and we welcome cooperators or potential user to cooperate with us and or to use this platform. Thank you.
Thank you. Thank you very much, Shijie. I think Shijie pointed out a very interesting idea that actually AI on chip, the platform is like the share economy, right? Everybody can use their expertise to really attribute a business. Okay, so next, I would like to invite Julian to share your perspectives in more in-depth.
Okay, I think the key word for us for heterogeneous integration is remove the wall, okay, which the wall will be in different portfolio. And I think for the IC manufacturing and design, that is in 2 different categories. So I was starting from the IC design first, okay. So the wall will be between that is mixed signal, and there will be digital IC and RF and system and packages. A lot of a different kind of idea. So we see that is competition is from the OSAT side and to the foundry side, because everybody would like to have a different kind of approach to make it more efficient about manufacturing for the new packaging, fan-out wafer level packaging and 2.5D or 3D. So there is a different idea that is some is using the organic substrate for the IDO, and some is using silicon interposer. So they different idea, but in the end, that is similar things. Well, it's all about the golden netlist and the reference design, and there will be have some kind of a manufacturing parameter, something like that. So how do we mix all the things together? Because in the IC side, everybody familiar about the GDS2, okay, and for organic for the PCB is called Gerber. So that is a different idea. That is how to make everything binding together first. And secondly, that is a different scale. Okay, for the IC side, that we're using the nanometer. For the packaging, that we're using micron. And for PCB, we probably have some millimeter things. So it's all about the 1 to 1 million scale compared portion. So the communication is so different. And we need to make sure that everything that is can communication with others perfectly. For example, like we said, is a pin pitch problem, how to connect each other. And we have a power problem. How do we transfer those power model into IR drop into the IC model, and can apply to the packaging and apply to the enclosure and system. So that is difficult. And we need to have some cross-domain collaboration, because you don't want those kind of things is like a waterfall. So everybody do the design and from the IC side and do the handover to the packaging and packaging to the enclosure. Everybody is hand over to others, but there is no closed loop can hand back those data and the engineering change back to the original design. So it is very difficult. So as an EDA tool vendor, that we have a different kind of idea. That is how do we communication with each other and make sure the data model can be communication between different tool and different model. Okay. So that IC side is used to using the Linux environment, and for the PCB side and for the packaging side is using Windows communication. Okay, so they're different platform that should be have a close and seamless communication between each other. So that is very important for everybody. And once we solve those kind of so-called standard, and we can do the platform is next mission is called flow optimization. So the flow optimization is based on two things. First is we have a so-called correct driven design. Okay, so we need to have a very strong or correct about constraint for your design, and you can hand over those things to your designer, and the designer can reference those kind of things to their design and hand over to the next step. So based on that you can back to the analysis part. So the analysis that is using different model, okay? You need to handle about hotspot for the IC side. You need to handle about the 3D for the EDI sims. So there will be a very difficult portion you need to conquer about the cross-domain collaboration issue. So Cadence as a tool vendor that we already conquered those things with our valuable partner, that we solve those portion by standardize and optimize those process to make sure that we can hand over those things to our customer smoothly, and that they can adopt the solution easily. So this is the things we are currently working on.
Okay, thank you very much, Julian. I think Julian just pointed out a very important point about how to standardize all the big data across the ecosystem, especially all the customers, they have their own recipe and their own niche. So everybody has concern. Sounds like Cadence already have some solution. So congratulations for that. Next, maybe for that topic, we could have our other panelists to maybe share a little bit later Okay, thank you. So next, I would like to invite Yuhua to share your thoughts. Welcome.
Okay. Yeah, currently, I think because of the semiconductor node shrinkage, so the more higher density and more finer pitch from the IC side request, the package side need to have a solution. So from the substrate, we got this kind of request and challenge. But honestly speaking, at this moment, we cannot achieve the request. So there's many kind of other alternative technologies. Some already be developed and some still under developing. So for example, for the silicon interposer, because of the substrate cannot achieve the very high density and also the chip-to-chip interconnections. So the silicon interposer 2.5D happened at the beginning. And after that, they have the info on substrate and fan-out on substrate. So those are the advanced, I would like to say advanced on substrate technologies because they still need the substrate. So even currently, there's also have the embedded silicon into the substrate. This is also the other way to achieve the high density interconnections. But still, if the substrate can make it, the customer also prefer adopt maybe this is also the other solutions to compare with the 2.5D or the info on substrate or fan on substrate. So they have the 2.1D substrate or 2.3D substrate. But for this kind of substrate technology, actually it needs the new investment because they are more likely the semiconductor or the packaging technology because they need the line space less than 5 micron, even the request the 2 micron. However, current substrate in the HVM, the line space are larger than maybe about the 8 micron to 10 micron. So there's a big gap. So I think the substrate manufacturing side, they are also considering to have this kind of capability of technology can offer I would like to say to offer the end users. But from our point of view, if we like to have this kind of capabilities, there will have a big change compared with the conventional substrate manufacturing. For this kind of manufacturing, for example, the foreign material control is very important. Foreign material maybe come from your production environment, come from your equipment, come from your raw material, come from the human. Because in the PCB and substrate, there's a lot of manual handling or the lack of the automations. So these are what we see the challenges for the to make this kind of advanced substrate technologies. So I think it will be a trend. Substrate makers still will keep their efforts to make it happen. But in the other way, substrate is a platform. They still need the IC or the other modules on the substrate. So the interface between the substrate to the packaging or IC, from our previous experience, we always be request or be challenged from the assembly side. there are many issues come from substrate. But usually, based on some kind of, I would like to say, confidential issue, we cannot get very clear information. If we cannot get clear information, it's difficult for substrate side to, based on this kind of issue, to improve our, I would say, our defect or our issue. So I would like to say, one suggestion, maybe in the future, currently they are the supplier, some kind of like a supplier relationship. Maybe for this kind of more advanced development, we need to set up a partnership relationship. The more and more information related with the issue need to be disclosed clearly. Otherwise, it's very difficult, just only from the one side. I think that based on both parties' knowledge and also the effort, maybe if the information is clear, we can solve this issue very soon. This is from the substrate size point of view.
Thank you. Yuhua just pointed out one of the major reasons why we need to conduct this heterogeneous integration panel discussion today. I think the most valuable part is the collaboration, is partnership rather than vendor and customer relation. Especially Taiwan is highly horizontal in industry. So we have individual OSAT, foundry, substrate, and two system. We are not like other region which have more IDN than foundry business. So we definitely need more on that. And I would like to echo what Yuhua just mentioned about foreign material. I think that's also one of the reasons that a lot of industry is now trying to install smart manufacturing. They want to lower the impact from all the uncontrollable, either it's human, it's incoming quality control, and all the different topics. So thank you, Yuhua, for pointing out several important topics. So next, I would like to invite Leroy to share your perspective.
Yes, thank you, Yuhua. It's a good idea about the partnership, while it's the most difficult part of confidentialities, right? And so actually, I'm the advocate of AI on chip, to be honest, of Shijie, because heterogeneous integration or AI on chip actually is, for me, is the vertical integration. So that's how I try to initiate the Blue Ocean Strategy Committee right back in my group. So for that part, as what I mentioned, whenever you have the internal partnerships, you won't really have too much of confidential issues. Otherwise, everybody need to sign the NDAs. So for that part of the communication, truly would be the challenges actually for the heterogeneous integration, how to facilitate the communication speed. For example, like as what we see, we are now at the 5G era, we are now at the AI era. Now everything is talking about the upload rate, download rate, but what I really care, the real bottleneck of the 5G or millimeter wave actually is bottlenecked by YouTube, to be honest. Okay, because they said that the bandwidth is how much? Is that you have to download the real throughput rate that would really make a sense. Okay, so I would say like the communication speed probably would be the big challenges for the big ecosystem, and coming down as what we have a good idea from the Julian, that the integration on the system or the wafer level idea, that for example, like with the Wi-Fi 1x1 plus with the Bluetooth low energy for the BT 5.2, then actually you may really have the capability of making a die, right? Or make it a SIP. But the real point out is how we really solve the interference issues to optimize with the real solution to go forward with the little small amount of the quantities that need to be manufactured. So those are factors into the one of the topics that actually would make people hesitate to move it forward. So And so what I understand for that, the issue is not the last mile, the issue, but the last nanometer issue for the real AIoT to boom. So that's what I understand for the challenges. But on the other hand, of course, that the opportunities is the one hand, two sides, right? So the opportunity is right there as long as you have the better solutions, like what we are doing with, for example, for our companies, like doing with the PMIC, or we try to minimize with not the FPGA, but we use the state machine, we draw back, not the N+1, but we N-2, okay, to optimize with the different packages. Similar like the Shiji's AI on chip, the solutions, -2 for the green pack solutions that we move forward to the customers that, okay, which the package that you really need. And then that would be good enough for you to add on for your specific features or the niche parts that to move it forward. We did it very successfully, right, in the PC industries for that part. And then the mobile industry right now is booming as well. So that's what I learned. So I would say this is not a challenge because we are already in the challenge. So that's the opportunity. Thank you.
Thank you. Thank you very much, Leroy. I think semiconductor has always been in challenge, but we always overcome every time. And I wonder if our member here today have the chance to join Leroy's Blue Ocean Strategy Group. That sounds very promising, you know. So we definitely want to have the opportunity.
You got to have your boss to approve for any project. So that is the Blue Ocean strategy. Very simple. Otherwise, you won't really get the funding to move for your dreams, right?
Indeed, indeed.
Right.
Thank you, Leroy. Next, I would like to invite Charlie to share your perspective.
Thanks. So learning a lot from other panelists. So I will share more from the marketing side. So first of all, on opportunities, definitely I think that IoT would need a lot of SiP technology. So I just mentioned that for some wearables, probably in the future, not just those ECG function, but also some temperature sensing and item tracking. They would need more integration of different kind of chips. So I think consumers they want more features, and the wearable or smartphone, these mobile devices only have a very limited space. So definitely there's a great opportunity. And second thing is the higher performers. And as I know, you need a better interconnects. Not just like a 2.5D interposer, but also in the future, fan out and it's OIC by TSMC. Those kind of interconnects maybe have a big breakthrough in terms of data transmission between chips. So definitely with kind of more promising AI applications, I think that is also a key opportunity to address. But on the other hand, the key kind of challenge I'm seeing is more than just a technical side, but also I think it's about the cost and also the demand. For example, for a millimeter wave AIP, the cost is around $20 to $30 for the SiP module. So in terms of the end product price, they could add around $100 retail price. So whether that can be affordable by consumer, I think that is one thing. And also, if you look at millimeter wave infrastructure, the coverage rate for the same base station is only 13% versus the traditional 4G base station. So that infrastructure cost plus the small cell deployment cost is going to be very high for the millimeter wave. So ultimately, the telecom operators or consumers or smartphone brands, they need to share their cost. And on the demand side, I think as long as we can see very good applications the users will be willing to pay for that. But so far, for millimeter wave, now we haven't seen, we see the concept, but so far that whether the demand can pick up remains a risk. So to summarize, I think the opportunity should be more features, higher performers for the devices, but the key challenge should be cost and also the end application. And also maybe in the Q&A session, I will ask one of panelists, what do you think about the business model? Because that integration will involve different parties from design partners, memory partners, foundry partners, and backend integrators. So what if there's a kind of low yield or the chip into scrap? Who is going to pay for the kind of low yield? So that will be my question to one of you later on, but I kind of propose it to you guys right now. Thanks.
Thank you very much, Charlie. Indeed, financial acceptance is always a very important thing for all the products go to mass production. So maybe later that topic we could have a representative from a mass production company and also from maybe 世界 AI on Chip to share a little bit more. Okay, thank you, Charlie. And next, I would like to invite CP.
Hey, looks like a lot of interesting topic has been selected. So I would like to bring up the opportunity from our hands. For example, when we are talking about SiP for heterogeneous integration, actually we can talk about 5G. That is a recent topic as a starting point. Starting from wireless connectivity, actually we can look back for 5 years. For example, when we are having wireless connectivity, SiP, we need to take care, for example, starting from 300, 400 components all on the same substrate, then inside the same SiP. And then nowadays, that keep increasing. Nowadays, we need to accommodate more than 1,000 components, including active chip and also passive chips. So actually the challenge also coming from that. We need to take care of those chip packaging. Also together with those shrinkage on size and also keep enhancing on the performance and also asking whether if we can have smaller components all the time, so that every one OSAT can really making it happen. And at the end, we even need to develop a new shielding technology to make sure that the wireless connectivity, the signal won't really interfere or being interfered. So a lot of new technology really based on that. So the pressure we can see is, even we are having a good idea, we want to shrink the total SiP every year, every half a year. And the challenge is always coming to push the chip developer, chip designer, packaging structure designer, and also process developer, and also the substrate technology developer, and also the process enhancing process developer. So also, the same challenge to the design portion. Even we are thinking, oh, how are we going to put that much component inside one single SiP, and then we want to make it a irregular shape. So can we have all those molding covered well on top of those components? So do we have right design tool for that? When we are taking care of component performance and then all the circuit already well linked, so how is the electrical, how is the thermal, how is the antenna effects, shielding effects? So at the end, with this revision, we can cover, say, hey, with that much component, yeah, we can do the molding well, but do we have right design tool that can help us say, oh, well, next month, 15 components from that SIP module, we are going to short. We are short of storage, and then we need to have new component to replace. However, the size is bigger. Do we have a quick turnaround design tool can take care of that? And if that comes from the active, well, Leroy just mentioned, well, maybe we have chance, well, with some of the new application, maybe we don't really need to use advanced node. Actually, I would like to use two-step back node. Well, your boss will probably appreciate you. When you do that design, that saves money, and you reuse IP. And at the end, the total cost is really dropping. And you are actually getting allowance, and then even if you can keep the same size, and that is another advantage of SIP. So all the way that is from a typical SIP development, the challenge that we can see. So I also see Charlie mention about AIP. AIP is also a challenging portion. When we are seeing those modules being made with such a large substrate, actually at the beginning, we are happy. Oh, that's the packaging business. And eventually we find out that size is like finger size of substrate. And that means all the money goes to substrate maker. So from the wavelength point of view, yes, that is a nice wavelength, millimeter wave that will goes into this packaging size. But the challenge is, do we have a chance to bring it to the smaller size like we do all the time for SIP? Then the second challenge comes up. Do we have the chance to bring the size smaller? And can we do a lot of different simulation to make that happen? And also, can we do that? Is that available that we can have that design turnaround and iteration right away with different design tools? So we can also making the right structure from substrate and also the right performance from the design tool. Because even up to now, for all the AIP design, we need to really take care from the design point of view, and then also packaging manufacturing, and also the final test with actual bin forming measurement to make it happen, to make sure the performance is right. So a lot of challenge, although that comes with a lot of opportunity. And the final things I would like to mention is 2.5D. That is a really complex structure. So a lot of our panelists has discussed this. So similar story, when we are making a lot of new function integration into this device, for example, multiple chip with HBM, or even multiple chip with partitioning structure. And the challenge is, well, actually, all of the chips are sitting on top of a silicon interposer. And that means actually we are having the silicon to take care of substrate function. So yeah, well, Yuhua just mentioned that, well, sorry, our substrate cannot take care of that high density. So our customer have to use silicon interposer. But somehow, when people are using 2.5D, they are also, because of the cost pressure, they are coming back to use fan-out on substrate technology. Although at the end, they all need substrate. So a lot of interesting opportunity and also challenges.
Thank you very much, CP. I just find out today that CP not only very good at guiding the group discussion, but also very good at asking questions. So I wonder if any of the other panelists would like to echo what CP just mentioned, either from EDA point of view, substrate, or maybe design point of view.
Maybe I can contribute some idea that CP already mentioned. I think the first things for the IC design or the entire industry, first is we need to talent. Okay, the first is talent. Okay, so we need to make a design and have an idea, and all the tool is to support for realize those value. Okay, so the first things. The second thing is like CP mentioned as many times is EDA readiness. Okay, we need to have those kind of capability first, and the designer can base on those capability to do the design. But in nowadays, that is many problems happen is actually they need to have a PCB idea, substrate idea, and they need to have IC design concept. Okay, because from the IC that is very simple, that is using so-called Manhattan routing. So there is a horizontal, vertical. That's all. Okay, so they're using a polygon for to describe their design. And for the PCB side, as we have a curve, we have a teardrop, we have a lot of so-called snake routing, everything. So those kind of any angle and any kind of idea that you can realize in the PCB substrate. So that is actually the two things should be put it together. Like maybe CP says that is okay. We have a limitation for those kind of design density. Okay, the very fine pitch. Okay, so that the maybe PCB substrate cannot do it, but the new technology coming is the so-called thin film that can go into even thicker for those kind of duty. Okay, so there will be another approach. So the substrate vendor that is goes to come across the end for the silicon things, and silicon want to using their remaining value for their old equipment to manufacture those kind of silicon interposer to everybody. So as an EDA vendor, that we try to do those kind of things to make sure that the designer is easy of use for those kind of things. So we can combine our technology called multi-technology to combine different kind of die. Maybe they're using the hierarchical digital IC and they have a mixed signal RF things. Like CP mentioned, that is we have a very hot topic for AIP. So we recently tried to do those kind of things to have those capability to put together, and not only for the design side, because it's very easy to link together. But the problem is that it's really functional and have a good signal and efficiency for their performance. So we recently have some collaboration with our customer to do the so-called multi-domain collaboration and the analysis for those kind of AIP solution. And we have a very good model that is starting from the RF to the PCB and include together with the substrate and the packaging and the IC side. So everything together and do once, not divide and conquer by each of a side and to solve those problems. And secondly, to make sure the EDA readiness is I would say perfect, maybe not perfect. We are on the way to satisfy about our customer requests. Okay, so they have many requests. We try to conquer those kinds of things. Like a CP says that we have a HBM that is goes to maybe 6.5 billion. Okay, item features in their design. So that is become very big. And how do we conquer those kind of performance issue to combine together with a multi-die to do the design? So we also need to have a push shell capability into those things. And maybe that we can do some machine learning to put those capability into the design and to make sure the designer and can be easier to adopt those tools, not learning from different sides. Okay, to do those kind of IC design and the PCB design together, so that can solve a lot of problems. So this is from the EDA vendor side that we can support our customer in this way.
Thank you. Thank you, Julian. Due to time constraint, maybe we move on to the second question now, and all our panelists could add on further of your thoughts there. Okay, so Taiwan has been very strong in semiconductor manufacturing, as we all know, whether it's from foundry, from OSAT, or from substrate. So second question, I would like to have all our panelists to share. What's the competitive edge of Taiwan in semiconductor supply chain? So for this question, firstly, I would like to invite Charlie to share from global consulting perspective of how you see the opportunities for Taiwan, the advantage.
Sure, thanks. So it's a kind of interesting time, especially during this U.S.-China technology war, and that represents Taiwan's strategic position in the global semiconductors. So I would say compare with China, I think Taiwan's advantage is, first of all, it has a big cluster versus China. Their investments is more fragmented, driven not just by central government, but also lots of local province, PE funds, governments. And also, I think the retention rate for Taiwan employees is much better versus China. They can poached by lots of internet companies, including our industry. But for Taiwan, I think the semiconductor remains to kind of the best and the most competitive industry for young people to work with. And I think for Taiwan, we are kind of market driven. We don't really depend on the government subsidy in the recent 2 decades. Versus China, I think lots of companies at the beginning they depends on government subsidy, but that continue and kind of lose their competitiveness. And versus China, I would say the disadvantage of Taiwan should be we don't have a very big end markets or that application. So I think 3 years ago, when Bitcoin mining is becomes a main industry in China, it's almost a Chinese company like BMA's market share. And in the future, we think AI and autonomous driving, and also those voice recognition, face recognition will be see a bigger end market in China. So I think those are kind of China local IC design companies key opportunity. And lastly, China has a much bigger capital markets. So if you look at a Starboard, there's attracting a lot of global fund flow to China. And then compared to US, I would say also actually lots of that quote from TSMC management's comments. I think compared to the US, Taiwan is more efficient. We got a lower cost. And I think it's also fair to say people in Taiwan are more diligent, easier to manage. And I think those are also very important thing to run the semiconductor industry. But compared to the US, I guess that for Taiwan is very kind of difficult to build our own IP or semi-equipment industry because there's need a lot of time and investment in the fundamental research. But given Taiwan is playing a kind of a strategic role here, so we are in a very good position to leverage those relationship and the technology from the US, Japan, and Europe, and enable the China semi-localization. So overall, I think we are in a very good position now. Not perfect, but I think we can continue to outgrow the global semiconductor. Thank you.
Thank you very much, Charlie. Just like Charlie mentioned, at this time when geopolitical competition has been more intensified than ever, I think how Taiwan can maintain its competitive edge is definitely very important for the next 10, 20, 30 years for our continuous prosperity for the IC industry. That's definitely a topic we need to consider. So thank you, Charlie, for pointing that out. And next, as Taiwan is very strong in foundry, in OSAT business. So basically like ASE, like Unimicron, their customers are worldwide. Everyone could be their customer. So next, I would like to invite CP maybe to share from OSAT point of view, how do you see Taiwan's advantage in this global competition?
Yeah, sure. Charlie, I would like to echo your point. Since Taiwan is in such a small island in very close distance, and it can be a good opportunity for us to really to trigger an integrated IP, but I would like to extend this idea to a strong connection. How do I say that? You know, every one of us from different segments of the semiconductor supply chain, we are taking care of our own portion only. And most of the time, we are doing business with customer internationally from every country, from every region, wherever they need design tool as well, or substrate, packaging, chips, then we can provide solution and provide service. So that is one working model. We do this all the time. Maybe there's one good way to show, to demonstrate, to really present our competitive edge. For example, our government can really stand up. For example, for smart city, smart traffic, smart building, and smart everything. And surely we are doing this smart manufacturing already. Why we are saying this? When for example, Zhang Fu, I'm looking at you to say this. Government, for example, when they are talking about smart traffic, and then they can say, oh yes, there's a smart sensor I can use first. Maybe smart camera, smart sensing for the traffic flow. Then when we are having that concept in mind, start from software, start from hardware. So all the target is, for example, when we are traveling, for example, typically 1 hour driving. If we are having smart traffic, we probably have chance to reduce that to 40 minutes. So that means a lot. We can save petrol and electricity for electric car. So from that calculation, if our government, we can stand up and say, hey, with that software and hardware system, so how are we going to develop that? See, your AI on chip program is a really coordinator. And when you set up that program, software we have, well, actually, you know better than me. You are from the university, you can share the comments. Hardware, for those sensor, for those MCU, for those processor, for those wireless connectivity, wired connectivity, for those substrate, for those design system, we are all there, we will support you. And when our government demonstrates this system in one single region or in one single city, wow, that is the way our government can also show, hey, this is the solution for our future city with super smart traffic. So that's a way to show our competitive edge. A example for our discussion. So that our discussion, we are not really limited to the semiconductor we are discussing at this moment, but we are really work together to show our Taiwan's strengths and strong position for all of your reference.
Actually, I do not represent the government. So even though E3, we have helped company to write government proposal, but as this ITA Alliance, I think that we have a lot of expert and also industrial leader like CP. I think we have very good position to propose some good idea to government. I think they will listen, as many of the industry leader that have certain idea. I think this will be a good platform for AI on chip. I think we can work on that later on. But as AI on chip, that a lot of the time I was questioned about what are the application for or AI on chip, right? What are the program or the application they can demonstrate all these strengths of like IC, AI chip, integration, software all together. But as CP also know that we have been looking, but it's not easy to find a good application. But CP just mentioned about this smart city. This could be a good idea, but it really need to have some of the commitment from some, say, local government or some high-level officer. That, as everybody knows, that a lot of IoT device they was used by public, not by consumers. So it really the government maybe need to have some very good plan so that all this new idea, new platform can be applied. I agree with you anyway. Okay.
Thank you. I very much appreciate what CP just pointed out. I think not only the industry itself need to be very strong, but also we need to have the holistic support from the entire infrastructure, including government's resource coming into to facilitate the entire industry to grow further. So maybe our next gathering, we could have a representative from government, maybe through Sijie's recommendation, to invite them to also share from government's point of view how they could help industry to grow together. Thank you. And next, I would like to invite Yuhua.
Okay. First of all, I would like to echo the previous discussion in the AIP. Yeah. So Charlie also mentioned about the AIP, and CP also mentioned about the AIP by using the substrate. So I think today we don't have a panelist from the material, right? Yeah. So currently, I think because of the 5G millimeter wave material, raw material, the material itself is a very it's a key. Yeah. So but how to define or how to prove this material is good or have a good performance in this kind of application? Currently, there is no standard. And also, by different kind of measurement method or different kind of process, the material property will change. Yeah, so the challenge is how to, I think that for the 5G and millimeter wave, the key is that you need to have a very precise or very tight process window to make a very uniform, no matter the thickness or the dimensions, this kind of substrate. Yeah, so I heard one customer told me, because substrate they have a, compare with the, because they, by using the fan out or by using the info, they also can make the AIP. But because they can control the process very precisely, so the performance is perfect. However, the cost is very high. So they still need to adopt the substrate AIP technologies. So I think if they have the method, can help substrate make a very good. I mean, they have some target spec. Yeah, if the substrate can make a very tight spec in this tight spec. Yeah, so I think we can offer a very good product, very wide bandwidth. Yeah, AIP. So yeah, this is for the AIP. Yeah. Yes. So it also related with the deny. Yeah. So we need to work together. Yeah, to have this kind of very good performance AIP substrate. And secondary, I would like to go back to the what's our competitive edge of Taiwan semiconductor supply chain. Now, CP just mentioned the high level, more high level. I would like to focus on the maybe more technical point of view. Yeah, so I think Taiwan is very unique. Now we are like the Silicon Island. Now we have the from the design, IC manufacturing, packaging, and substrate. We are all in the worldwide top 3. I think majorly our manufacturing side is worldwide top number 1. Yeah, so compared with the other country, yeah, maybe for the IC design, maybe in US is number 1, but for the other production side, maybe located in the other country. So I think we can use this kind of advantage to increase, or to prolong our competitive in the semiconductor in this Silicon Island. And back to the other for the E3, yeah, because I also came from E3 before. Okay, in E3 they have one project. We at that time I cooperate with the biggest sensor companies. Yeah, they are very surprised. Yeah, why they have such kind of research institute, have all the things in just one location. They have the semiconductor, material, mechanical, and medical. Yeah, 4,000 or 6,000 to 6,000 people just only located in one area. It's very convenient to such kind of integration. So I think Taiwan also, our manufacturing side is also like this kind of situation. So we have very good opportunity can prolong our competitive in the world.
Thank you very much, Yuhua. I think Yuhua just pointed out something also Charlie mentioned earlier about our uniqueness of semiconductor cluster that could really help us to sustainably, to be successful sustainably. Of course, I think the success of Taiwan semiconductor supply chain or ecosystem is not only contributed by Taiwan's, local manufacturer. A lot of multinational companies, they also expand and localize their business here in Taiwan to support their customer to success here. So next, maybe we could have Julian to share from Cadence perspectives on this.
Okay, I think that we mentioned about our competitive edge for Taiwan, and I think that we go back to heterogeneous integration. I think the keyword to Cadence is 2 words. Okay, it's collaboration, and the collaboration goes to modularization. Okay, because only if you can modularize, divide into small portion that you can do the collaboration. So we base things is build some community together. Like we already have our IC cluster, and the industry is located in nearby. Okay, for 300 kilometers away only. So we can work together very closely. And based on that, that is our observation in the past. That is everybody's work alone. Every kind of industry is working individually. Like IC design house, they do the design first and hand over to whatever their target manufacturer. Okay, so the keywords goes to lower price. Okay, higher yield rate. Okay, it's just cost down because that is everybody's familiar about that. Okay, but now is everybody like to have some add-on value. Okay, that is goes to value up. Okay, so those kind of things that is to bring a different kind of society working method. Okay, so everybody is trying to work together with their partner. Their partnership with their upstream and lower stream to work together. So they have an early stage collaboration. So they're starting to exchange those kind of idea. That is, if our manufacturing cannot do those kind of things, that will be very difficult for us. And if I need to have a very high cost for the material or specific technology that will be in fact to our year rate. So it's not the most benefit things to us. So we need to work together with our partner. Okay, for example, there is from TSMC's, they say they have a EDA partner, IP partner, and design center partner, and everything. So they say, I only have a 1,000 engineer, but I have a 10,000 engineer work for me. Okay, so this kind of idea is actually work together in our society here. So now there is we saw that is the IC design house in the early stage. They try to build a model, and they send the model to their manufacturer, like OSAT, to the substrate, to the foundry, or whatever, that the different kind of a target. Okay, they work together with them, and to build those kind of I would say analysis model. Okay, and this closed loop for their design process. Make sure everybody can survive and can easy to conquer those kind of things. And the most difficult thing is EDA tool need to be support for it. And another thing is we also need to consider about the so-called security issue. Okay, so everybody try to keep the business secret into their organization, but everybody disclosure their business know-how to their upstream. So that is almost not possible. So EDA tool as a vendor to hand over those kind of critical data into different kind of organization. We try to make sure everybody can work together with those collaboration model. Okay, so like people says like CP and Yuhua says about the AIP. So in the early stage, we already notify and be aware that is kind of a need from our customer. They need to build those kind of model to make sure everybody can work each other perfectly. So we try to support those kind of things. And also that is including from the interposer, from the substrate, every kind of thing. So they have a C4 bond, micro bond, different kind of a BGA, LBGA models. So all those kind of different kind of things is need the EDA readiness. So EDA readiness, one side is the design side. We have a capability to build those kind of connectivity. Easy says is NetList and the reference design and PDK. And another thing is we try to build those capability to help you to, before you tape out, that you can have a analysis capability to make sure those kind of simulation about the power, about the signal, about the thermal, everything that is awareness interfere with each other to make perfectly. So this is our position and try to help our supply chain to work perfectly. So this is our side. Yes.
Thank you. I appreciate Julian mentioned about value up, right? Instead of lowering cost. That's definitely the way we should take. I would like to invite Leroy to share your perspective for the second question.
Yes, thank you. So I would like to maybe recap about what in Charlie's mind. It's probably when he's interfacing with his customers, he only talk about one word, EBITDA, right? You only talk about the profitability for your manufacturing. The rest is, well, I think you have a very good concept, but give me the money, show me the cash. So that part actually is the most hardship from our design industry right here, because we got to burn with the 3-year money to keep forward. So I would like to highlight that I think that thanks to those pioneers like Stanshi, Morris, Zhang, coming back to Taiwan to give us with the opportunity for the coming next 30 years, 40 years. As what I see, we put a lot of efforts in the industry about the application engineering. So that you can see those ecosystem with the flourished ideas that to move it forward. Well, on the other hand, I would like to say that think about another jump out of box idea that coming from the Apple iPhone actually gets more than 98% of the probabilities back in the whole smartphone market of the 2 billion units. Think about that. I was very surprised that when we really check inside, there are a lot of SIP, all the SIPs and that what we are discussing right here, recapping with those the AI on chip ideas, I think the profitabilities they foresee about how to sip the die and then try to move it forward, even the coatings on the CPU to remove the heat. So I would see this good opportunity right here about the application engineering to see the different applications to optimize and then try to remove the spec N+N-2 spec to move it forward. But while I would like to say that we have a lot of the good entrepreneur from for example, like from the AI domains, that they are not really familiar with the hardware, for example, that how to go with the globalization and localization to manufacture. This is what our company is doing from the remote 31 sites to really move it 24 hours, the design to keep moving with those talents, because talents won't really just sit in one place, but they are everywhere in the world. How you optimize it or how you really find your niche point for the specific application to boom. Actually, only one specific applications, even from the AI part, is what I know from the friend, that they could make very, very good fortune with just 3 people, from the insurance company to the property insurance, how to minimize the expense of the cost, then they try to survive. So that's how I find the opportunities and from this ecosystem as the function of profitability with the globalization, with those application engineering, with those different good, like the SIP as what I see for the next stage, or the maybe AIP for the pen for everybody, right? Or the SIP for everybody to move it forward. So that's how I see the opportunities right here for the next.
Thank you, Leroy. As a lot of company, as the impact of COVID-19, a lot of nations start to discuss if they should localize all the manufacturing line into their nation. And I think what Leroy pointed out, an alternative perspective is about localization, also about how to bring global values and also local strength together to make things possible. Okay, so next, due to time constraint, we would like to move on to the question session. We have received quite a few questions from our chat room. And I would like to thank Albert, our co-chair from the Packaging Testing Committee. Albert has mentioned several questions, but there's one that goes to all the panelists. So could we change page to that? Okay, so it should be question 6. Of course, this question could be a bit sensitive, but we would still like to hear from everybody, because business is the part that we haven't get a chance to discuss a lot. So maybe we could address from this one. The question is, do you think COVID-19 or US-China trade war reason issue will negatively impact or slow down the development of 5G and AI or not? Why is it? So may I have volunteer for that? Maybe Leroy?
Is it me? Do I volunteer? I assume I volunteer. Well, I think that during the competition, I would say, like, for example, the sympathy rivalry is actually a positive wording, better than the negative ones. That if we are seeing with the issues right there, I'm seeing more opportunities right here in development of Taiwan for the ASIC, the ASIC opportunities to have the license and then with those IPs to be developed locally. Well, it takes time. So how to find with the transitional solutions that can move it to the next stage, I think that is the most urgent case. And currently, I believe that for the short term, politically, probably that would be one of the bargain powers in between, right? And then for Taiwan, I think, as what I mentioned before, that's if we could really focus on addressing our strengths of application engineering and together with the ASIC and with those outsourced innovations from the other continentals, probably that would help the situation and ease the pain. Nobody could really forecast about if any IPs on any equipment of the semiconductors cannot be leveraged, then what would happen? I think that would be another total another story. Well, percentage-wise, I think things are solvable unless that when two people sit down, they can talk. And then I believe that there will be solutions. Thank you.
Thank you. And I got another volunteer, Charlie, from Morgan Stanley, who would also like to address this question. Welcome, Charlie.
Thanks. Yeah, so I think for 5G, I think China and outside of China, looks very different because China, they just announced they want to sponsor that new infrastructure, and 5G base station is kind of one of the key items. And also, I think for China smartphone makers, they do want to use 5G to counter the recent smartphone demand weakness. For China, I don't see that 5G is slowing down or delayed. But outside of China, in particular, some region like Europe, our concern is that their budgets for 5G infrastructure may shrink because they also need to deal with the healthcare pandemic. And also, in the past, they can get cheaper equipment from Huawei. But in the coming years, if Huawei cannot resume the operation, probably they need more budgets to build the same coverage. So I think globally, I think that they should have some negative impact. In opposites, AI, we don't see any slowdown outside of China. Those AI projects, ASIC design, as literally just said, are still ongoing. If you look at some design service company like L-Chip or GUC, I think Julian should also know very well. I think this year, even PC and cloud are showing some slowdown, but AI, those are chip development. We don't see any slowdown so far. And NVIDIA, their AI data center chip demand remains to be very strong. But in China, I think there could be some impact because if you look at the U.S. entity list, they really focus on those AI and surveillance companies, including previously iFlyTech, and also recently those surveillance facial recognition company. So I think China as the biggest end market for AI, I think some of the companies already get restricted by the U.S. technology. So China AI, I think there will be some slowdown. That's my kind of humble opinion.
Thank you very much, Charlie. Anyone else would like to add on to that question? Okay. We have many questions online, so maybe we go to another one. For another question, maybe question 1. This one goes to OSAT and substrate. So the question is, how OSAT and substrate players can compete with foundry fabs, since it seems like only high-end advanced manufacturing technology, such as TSV and hybrid bonding, can effectively enable AI applications. But it belongs to core technology to foundry, not OSAT and substrate players. So maybe we could have Yuhua to share your perspective.
Okay, thanks for the Albert's question. So, as I previously mentioned, for this kind of advanced packaging, they still need the substrate. So, actually right now, due to this kind of request, the substrate will become bigger and bigger and more highly account. So, from substrate side, we are the challenge from majorly from the challenges of the manufacturing because of the bigger substrate and highly account. by current manufacturing side, the yield is very challenging. The yield very low. So, for example, if the substrate unit size bigger than 90 by 90 millimeter, in our our substrate panel, just only 16 units. Yeah, and also the layer count currently is more than 18 layers, even more than 24 layers. So it means a very long production time. Usually it will take 2 to 3 months for this kind of substrate manufacturing. So for AI or high performance computing, yeah, the substrates still have very big challenges. Yeah, not just only to scaling the 9 pitch or the 1 pitch, but from the manufacturing side, the challenge is even bigger because we cannot have a maybe for example, for my previous mention, yeah, for one panel, just only one or two good units. So they will have a very high substrate cost. So how to reduce the cost, yeah, and also increase the yield is our challenge part. So for this kind of challenge, I think the current they have several I would like to say is foundry-like substrate manufacturing. Right now is under building. Yeah, maybe not just only Unimicron. We also have some competitor. I would like to say competitor, not competitor. Yeah, yes, yeah. If the technology is just only one company can provide, usually it will not happen. Yeah, because the customer don't have the bargain power to negotiate the price. Yeah, so we need to have such kind of same substrate platform, yeah, to provide a reasonable cost to the end customer, end user. So I think at the end, yeah, very good cleanliness manufacturing environment, precise or the uniform production equipments, and also the highly automation production flow, yeah, will be requested. Yeah, so this is my point.
Thank you. Thank you very much, Yuhua. Point out a very important keyword, co-opetition, right? So next, I would like to invite CP.
Yes. Actually, if we are looking at the solution providing point of view, there's competition between OSAT and the fab. And actually, it's only one fab doing that. But from user point of view, the good thing of it is, for all those chip integration, we are seeing more solution coming up. In the past, for that many chips integration, we are only seeing flip chip. It's offering a high density integration. However, for 2.5D, so in 2.5D, people are using silicon interposer to do the integration. So that is a good part for people to put that much high density I/O, that much chip together to integrate them. So we haven't seen performance like that before. So that enable, for example, a typical total package I/O that can accommodate that much chip totally together. For example, over 200,000 I/O can be 1 million already. That's already happening. So without that technology, we won't see that. So also at the same time, when we are seeing that happen, so it's every high density device, are they all needing that technology? So people start to step back and say, oh yes, for some high density device, I need that 2.5D structure. But for people to find some AI application chips, for example, GPU, and they start to think, and even including FPGA, they start to think, with some of the device, I can simply using fan-out on substrate structure. That can cover that beautifully. So again, that is the solution. Without those new 2.5D, we won't be stimulated with alternative idea. So that can really helping us and push us to make those alternative technology in place. So that is what happened in past 5 years. So actually from industry point of view, especially user point of view, we are sort of welcoming that. And even nowadays we are thinking, well, if substrates that can really enhance those fine pitch layout, line spacing capability, can substrate take care more? So that they can have a good balance on performance, also on the cost. So maybe I'm talking about maybe using a less fan-out layer. So that is a nice story. We are seeing it. It is very good from the industry point of view. And again, we need to appreciate this one single fab. They are actually bring the technology to the market. And also that is also demonstrating a very good way in the future technology, including, do we have chance to do more solution? For example, with wafer to wafer, multiple chip to wafer, then we do the singulation, then we do the assembly. So that is a very good opportunity. All of the users, they can really design with all those flexible device all together, then always take advantage of the different packaging solution.
Thank you. Thank you very much, CP, for the summary. Due to time constraint, actually, because we still have a question coming in, but I'm afraid we might need to stop here. So first of all, I would like to thank all the panelists for the outstanding sharing. Let's give them a big round of applause. And through today's discussion, I personally am very confident that heterogeneous integration will definitely lead a new way for continuous IC innovation. And for a lot of questions that, or a lot of keywords that all the panelists just mentioned, if our online audience who would like to find out more about what's the next step of heterogeneous integration and what's the future development of SiP, SLC, and all the cross-ecosystem collaboration, I would like to urge you to all join our SiP event in upcoming September. Our event will be from September 22nd to 25th. And as I just mentioned, we have several topics confirmed already, and our theme for advanced packaging, SiP, and also Moore's Law 2.0. And we look forward to welcoming all the attendees online to sign up for this event. And of course, I hope all our panelists will be there to join in with us. And yeah, if you would like to get access to today's recording, please scan the QR code from the screen that you could see here. And also, we would like to hear from you about your feedback to today's panel, and also what else that SEMI could do to bring more values to the industry. So please share with us your thoughts. Okay. And lastly, I would like to thank all the attendees and also our panelists for joining us today. And we look forward to seeing you in September. Thank you. 谢谢。Roy， 第一次跟您见面，觉得未来的活动我邀请。
要把它第二嘛。
谢谢张副。谢谢 Julian，Thank you so much。谢谢。那我们这个请大家我们一起，我们的 HR 五月天。一直整合五月天。对，好，没问题。好 ，Charlie， 我们线上会再寄给你哦。
好，谢谢，或者是那个敌人帮我拿也可以。好，谢谢喽。好，那下次见喽。
那我们要那个吗？手比爱心吗？对，这是爱讲，爱一加爱心。